Alright, here's a demonstration of how to do a dihybrid cross. First, the hybrid crosses are when you have two parents and two traits. So we'll use heterozygous because that's probably the most complicated situation you'll get. And then you'll cross it with another heterozygous because that's also the hard situation. And then we can try this out. So start with, we could either do one big Punnett square with 16 squares, or we can use our favorite tool called probability, and we can do two Punnett squares, and you can use the fact that these are completely independent probabilities, assuming no linkage, then you can combine them together. So we can start with, for the trait, for the A gene, we can do this, and then for the B gene, we have parent 1 crossing parent 2, so it's the same idea. So then that should give you, in terms of a genotype, we have that 1 to 2 to 1 ratio, 1 homozygous dominant, 2 heterozygous, and 1 homozygous recessive. Likewise, we have the same thing here. So now what we can do is we can combine these together. So let's start by taking a look at our genotypic ratios, which is 1/4 is AA, and 1/2 is a little a, and then the last 1/4 is homozygous recessive. Likewise, we can take a look at the same thing, and it's exactly the same thing here, because they're both heterozygous cross heterozygous. So now the magic is we can do to figure out our genotypic ratio. Say you want to know what's the likelihood that you can get an offspring with 2 dominant A alleles and a heterozygous B, then what you can do is you take the probabilities, and because these are independent probabilities, we know that we multiply them together. So 1/4 times 1/2 is equal to 1/8, for example. If, on the other hand, you're looking for a phenotypic ratio, then a dominant phenotypic ratio for both of them, well, we see 1, 2, 3, 3/4 are dominant phenotypic, and 3/4 as well here. So then you would see 3/4 times 3/4, that's going to be a 9/16 chance of having a dominant in both traits phenotypic ratio.